Hi everyone, so today we're going to solve Leetcode daily challenge problem number 876, middle of the linked list problem. So in this problem what we have to do is you have to figure out the middle node of a linked list, and if there are two middle nodes we are going to pick the second one. So we are going to solve this problem with a very interesting approach which I learned you know a while back, and I don't exactly remember where I learned it from, but we are going to use two pointers, a turtle pointer and a rabbit pointer. So basically, it correlates, or it is linked with the story which we all have heard about, a race between a turtle and a rabbit. Okay, in which rabbit was the faster one and the turtle was the slower one. We are going to use the same exact logic, and what we're going to do is we are going to initialize both pointer with the first node, and with each iteration, what I'm going to do is I'm going to move my slow pointer a single number of times, but the fast pointer will move two times. Okay. For example, if the pointer was at 1, like both the pointers at 1, in the next iteration, the slow pointer will get to the second node, and the fast pointer will go to the third node. And we'll continue to follow the same step until we reach the last node. Okay. Or, uh, yeah, like until we reach the last node, essentially. Okay. And at the last, we are gonna just simply return the total pointer which will represent the middle element of our linked list. So let's start code and let's see. Okay, so we're gonna initialize our total pointer and our sorry, rabbit pointer with head, and we are gonna run our loop till uh, the rabbit pointer is at the last valid node, or and it has a you know it has one more node at the end at least. And what I'm gonna do is we're gonna move the total pointer a single time and the rabbit pointer double. So intuitively what is happening over here is when your total pointer reaches the middle element, your rabbit pointer must have either iterated through the last node or will be pointing at the last node. So this was a very easy concept for this problem. And one more interesting fact in the meanwhile, we'll submit this for test cases. And one more interesting fact about this particular approach is you can also check if a linked list has a loop in it or not. So when you submit the solution, and if except the initialization part, if your both pointers meets anytime after that, they both point to the same node, you can simply say that yes, like the linked list has a loop in it. So yeah, the solution performed decently well, and the last time I submitted the same solution, we were getting 92% of the 92.5% of uh, what do you say, better runtime results. So thanks a lot guys for watching my video, and stay tuned for the upcoming ones. Thank you.